So today we're just gonna talk about physics, specifically motion and forces, which is just how and why things move. It's gonna be the first time we're gonna touch really on physics stuff. So basically, physics in general, right, is a science that focuses on trying to understand and explain natural occurrences that happen all around us. We study matter, motion, and how it occurs throughout space and time and things like that. Sorry, guys. Okay, so if you guys are wondering, what really is motion? Motion is just a change in position over time. If something moves from one place to another, then we call that motion. So I'm just going to start off by playing a quick game with you guys, which I have some objects here. And I'm going to ask you, is this object in motion or is it not in motion? And then you guys can unmute and tell me. The first one is just this tree right here. Would you guys say that this tree is in motion or not in motion? You guys can. Oh, you said you think it's not in motion? Okay, that is. Oh, oh. Totally. Okay, that is correct. The tree is not in motion. Okay. The next thing is a bus. And I know you can't really see it right now, but let's say the bus is, on its way to school. Would you guys say that that's in motion or not in motion?
In motion?
Yes, correct. Okay. What about this chair?
Not motion?
It's not motion.
Yes. Okay. What about this running dog?
It's motion.
Yes. Oh, I keep doing that. Sorry, guys. Um, okay, back to where we were. Okay. Yes, it is in motion. What about, let's say this plane is flying in the air. Would that be in motion or not in motion?
Um, in motion?
I'm sorry, your headphones are just a little bit muddled. You said it's in motion or it's not in motion? In motion? Okay, that is also correct. You guys on a roll. Okay, what about this last one right here? This kid is kicking the soccer ball. Is that in motion or not in motion?
In motion?
Yes, you guys are 6 for 6. Okay, so now that we have that covered, we know when something is in motion, we know when something is out of motion. What things that can affect motion? What things that can cause objects to go in motion? And what can cause them to get out of motion? That is where we talk about forces. What is a force, right? A force is a push or a pull on an object. And forces can do three main things. They can make something start moving, they can make something stop moving, and they can make something change direction or speed. For some examples of that, whenever you kick a soccer ball, that's in motion. But also whenever you catch a ball, that's also, sorry, I said the wrong word. Whenever you kick a soccer ball, you're applying a force to it. But also, whenever you catch a ball, let's say, you're also applying a force to it because you're causing it to stop moving. So the first one is an example of a force acting on an object by causing it to go into motion. And the second one is an example of a force by making something stop moving. Okay. Can you guys just give me a few examples from like everyday life? What are two things that require a push?
by pushing a door.
Yes, that is one. Does anyone have another one?
So it's like so push something like it's like your goal to do something.
That's one definition of a word. But in this case, let's think about it in terms of what can I push for it to start working, or what can I push to just cause something to happen? Okay, I'll give you guys two examples of the first one, and then maybe you guys are able to get what I'm trying to say in the second one. Like you said, Julie, a door works. We can also push shopping carts. We can push heavy objects. We can push people, things like that. Um, so with that being said, do you guys have anything in mind of two things that require a pull? Yes. You guys don't have to raise your hand. You can just say it.
So like two things that can like require a pull is like since you said a shopping cart, you can push that, and you can also push like a box that's like filled with things, or
Mm-hmm.
like or like other objects, but they're like something bigger and something else.
Okay, okay.
Also pull the door, like the door.
Yes, you guys are both right. You guys are a little too smart for me for this question. The two examples I gave of what you can push are also things that you can pull. That's also true. I was just trying to get us all to think of different things in different ways. But let's say you pull open a drawer and you pull it open, you pull a wagon, you bring a wagon. You can also push a drawer closed. You can also push a wagon. You can also pull it. So for all the examples I gave, they work for both pushing and pulling. Okay, so moving on, we're talking about forces right now, right? And there are different types of forces. I have some of them listed here. The first kind is gravity. I think this is probably the most notable force that we see. It's why whenever we jump, we don't just, stay in the air or float up to space. We are pulled back down by gravity, which gravity it acts to pull objects towards the center of the earth. The next one we can talk about is friction, and that is a force that slows motion when two surfaces rub together. Another common one that we see every day. The next one I want to talk about is air resistance, which is also called drag, and it slows objects moving through the air. Drag and air resistance is actually, I have them listed as two different things, but drag and air resistance in general is just a different kind of friction, but they're both friction. Another force that I have here is magnetism, which is a force that attracts or repels certain materials. Do you guys have any examples that you might be thinking of for any examples of these forces that I have listed? Yes? You can go first, Nasi.
Okay, so like so you're talking about friction, right? And so like friction, well, an example, um, friction is like inside a car, you're stopping the brake, and another friction is the like uh like some instruments, I think, because it's like there's friction and it's like is probably inside instruments, and it's like I think guitars or violins, because like you can play a note and then stop it. So
Okay, okay. I like your examples. I haven't heard those ones yet. I like your examples, yes. You can also go, Julie.
Magnetism, like I magnet my clipboard and I put it my magnets and put my notes in there. Also gravity is like I drop my hat and gravity pushes down, and also I think it's air. It drags it
Yes,
because
yes, yes. You can keep talking if you wanted to. Sorry, I didn't mean to interrupt you.
no, that's fine. I don't want
Okay.
to say anything.
Okay. Oh, I'll turn my camera on because you guys both have your camera on. I don't want you guys to feel like that or anything. Okay. Hi. Okay. Um, yes, you guys are both right. Those are good examples. Okay. We're gonna go to the next topic, which is Newton's laws. So basically, things like gravity, right? They were first discovered by a guy. His name was Isaac Newton, and he was a physicist. And he has put forth most of what we know about physics today, and he heavily contributed to just the world in general's understanding of how everything works. He had three main laws of motion, and I don't have it listed here, but my other slides go more in depth, so I'm just going to go straight to that. Okay, so Newton's first law is called the law of inertia, and it states that an object at rest stays in rest, an object in motion stays in motion unless unless an outside force acts upon it. Now a good example of that, right, is let's say a soccer ball. You have a soccer ball and it's sitting on an empty field, right? What's going to happen to that ball if no one kicks it?
Um, it's going to deflate.
It's going to what? Sorry, I didn't hear you.
It's going to deflate.
I see what you're saying. I see what you're saying. Let's say though that it's like already inflated, the place where you inflate it is closed off. Just like in terms of motion, sorry. Like, is the ball going to move if no one kicks it, if no one touches it?
It's going to stay like it was.
Yes, yes, yes. That is an example of Newton's first law. We can use this for everything really. I mean, let's say, your computer in front of you or whatever you're using. Is it going to move if you don't touch it? Which is of course, yes, no. That's what he means by his first statement whenever he says an object at rest stays at rest. Now let's think about his next statement. An object in motion stays in motion unless an outside force acts upon it. So whenever we first think about that, right? Well, let's say I do kick the soccer ball and it does start moving. Why does it stop? Can anyone tell me?
Um, because like when you you kick it, um, um, so it goes like with the force. Then after it stops because you're not like going to kick it another time.
I see what you're saying. I see what you're saying.
Uh,
Okay, no, see it. Yes, and you say.
so um, like if the soccer ball stops, it's like because you didn't kick it with enough force or strength. So
Okay, okay. I like you guys' theories so far. Julie, you want to say anything? No? Okay, it's all good. I like you guys' theories. I like that you're thinking. Let's try to think of it a different way, though. If what Newton is saying is that an object, which in this case is our soccer ball, is going to stay in motion, which means after we kick it, it'll keep moving until another force is acted upon it. Didn't we talk about a force that I'll go back to the slide actually. Hi. Didn't we talk about a force that slows something, that slows motion of an object whenever two surfaces are touching? If we think about it, let's say, most times we're playing soccer on grass, right, on a field. So wouldn't the soccer ball and the grass of the field and the ground be rubbing together after we kick it?
Yes.
Yes, yes, yes. Which is why the soccer ball stops. After we kick the ball, even though we uh, acted upon it and we caused it to start to be in motion, we caused it to start moving, the friction of the ball and the ground will cause it to stop moving. And that's why whenever we kick a soccer ball, it doesn't just go on forever and ever and ever. Okay, so that was Newton's first law. And Newton's second law is force equals mass times acceleration. That's the kind of equation that we get out of his law and what he's saying. But Newton's words were basically, sorry, the more force you apply to something, the faster it moves. But the heavier something is, the harder it is to move. So whenever we think of this law, it might seem a little bit like common sense at first. Like, of course, if something's heavier, it's going to be hard for me to move. But even so, putting it in simpler terms, let's say we have two boxes, right? One of them's an empty box, and one of them's a box filled with things, filled with stuff, as you can see. Which one do you guys think is going to be easier to move?
Um, the box that is um uh, um empty.
Yes, yes, yes. It's going to be the box that's empty. And um, in addition, let's say we have a really, really, really heavy box and a really, really light one, as you can see. If we apply a force to it, which one do you think is going to move faster?
Can you repeat the question again?
Yeah, of course. So let's say the two boxes that I have on the screen, right? If you decide to push it, which one do you think is going to move faster?
Empty one?
Yes, yes, yes. And that's basically what his second law is saying. It's relating mass and force, or mass and acceleration to force, and vice versa for the equation. Okay. Newton's third law was called the action-reaction law. And what it says is that for every action, there is an equal and opposite reaction. And now, the reason why I have this animation on the screen, this one right here, is because we can see, we don't see what the person is trying to push, right? But whenever he's trying to push it, you can see that he kind of falls back a little bit, right? Have you guys ever, I don't know, have you guys ever pushed someone? I'm asking a question. I'm asking. Have you guys ever pushed someone?
Yes, a lot of times.
Okay. Have you ever pushed someone who is a lot bigger than you? And have you ever noticed that? Have you ever noticed that whenever you try to push them, you yourself, you feel like you get pushed back.
Yes.
That's
Yes.
an example of this law. Basically, in this scenario, right, you're pushing someone. For every action, the action being that you're pushing someone, there's an equal and opposite reaction. So as hard as you're trying to push that person, essentially you're pushing yourself the same amount backwards. And that's what this law is saying. Okay. Now we're just going to do some examples of Newton's laws. Um, so I have three scenarios down here, and then I'm going to ask you guys which law applies to which scenario. Okay, starting with the first one, let's say that, I know this kind of may be a little bit of a bad visual, but let's say a balloon it gets popped, right? There's a hole in the balloon somewhere. And so air starts rushing out of it and it starts flying backwards. Which one of Newton's laws would you guys say best describes or explains this occurrence?
Um, a shopping cart.
What'd you say?
A shopping cart, or am I wrong?
No, sorry. No, it's not your fault. I just need to rephrase the question. Um, my question was that like for each of these three scenarios, right? Newton's like they can each be explained by one of Newton's laws, basically. So we can start with the shopping cart one. Maybe that'll
Oh,
bring
okay,
us in.
okay, thank you.
Mhm. Um, so yes,
Sorry,
scratch the balloon for now. We'll come back to that one. Let's say um we're like, you're in the grocery store with your parents, and they let you drive the shopping cart. And whenever you start pushing harder on the shopping cart, it starts to move faster. Which one of his laws would you say explains that?
Um, the um, the shopping cart. It's of Newton's law is like I think it's force and acceleration.
Hmm. So that one is Newton's second law, which is having to do with force and acceleration, things like that. That is correct. That is Newton's second law. Now that we did the first one, let's go back to the first question. So let's say I'll try to depict it better. There's a balloon, right? And let's see, someone pops it, and all this air starts, rushing out, and the balloon, in the opposite direction, starts flying backwards. Which one of Newton's laws would you say best describes it?
Uh, can I go?
Hmm?
Can I go? Like answer the question.
Oh yeah, yeah.
Okay. So, I the law that the balloon law is not the balloon law. What um the first question for Newton's law is um action reaction.
Yes, yes, yes. So that is, oops, sorry, no, backwards again. That is Newton's third law, the action reaction law. So that one best describes this balloon scenario. And like you said earlier, Newton's second law, which is force equals mass times acceleration, best explains the second one. Um, for the third one, the third scenario is that a book is going to stay on your desk until someone moves it. You guys might have, a couple books on your desk, maybe it's on your bed, things like that. And obviously, it's not going to move unless you move it. Which one of his laws best states that?
Can you like give the first letter for it? Because I feel like I know it, but I don't know like the rest.
I think it's the first one that it stays as is, but I forgot the name.
No, no problem, no problem. But yes, you guys are correct. It's the first name. But I'll go back to that slide. It's the law of inertia. Oh my gosh, I just realized that I didn't put the definition. Um, flooding out, and the cart moves faster whenever you push harder is an example of number two, which is the second law, having to deal with force and acceleration. Force equals mass times acceleration. The harder, the more force you put upon an object, the faster it's going to move. And the faster something moves, uh, the more force it was acted upon it. And the third law, and then sorry, the third scenario is best explained by the first law, which is the law of inertia, which is something at rest will stay at rest until it is acted upon by an outside force. Now, since I know Julie, you weren't here for the last two meetings, but basically at the end of all my lessons, I have something called an exit ticket, which is basically where I ask you guys questions over the things that we've learned. And then you guys answer them so that we make sure that we all understand and understand what we're supposed to get out of the lesson, basically. And the first one of those questions is, what is motion? If anyone wants to tell me. Yes? Oh, no, see, were you trying to raise your hand? Okay, I guess not. Okay. I think that you guys all know what motion is, but you just don't know like what the right way to phrase it is, if I'm right, which is fine. Basically, how we're going to classify motion scientifically is a change in position over time, which is nice when you think about it. You think about motion, moving. You're moving from one place to another or wherever that may be. And essentially, what is just changing your location in general terms, in speaking terms. But scientifically, we're going to classify it as a change in position over time. Okay. The next question is, what is a force?
Um, a force is a like a powerful um a powerful like like I don't
I know what
like
you mean.
how to
You know what it is.
explain
You
it,
know
but
what
like it's
Mhm.
like yeah.
What,
Um,
Julie?
is it like a push or pull?
Yes, that is the definition that we're going to use. That's the physics definition of it. Okay. The next question is, can you guys name two kinds of forces and what they do? Nothing?
So one force is properly a magnet because it has like since if it's like there's anything metal like the magnetic force like it will go to the metal. And the second thing type of force is like an apple falling to the ground because it's like a gravity force.
Okay, I like that you give me examples. Those are two kinds of forces. I don't have magnetism on here, but you are right. That is one of the kinds of forces that I talked about. But yes, you talked about an apple falling, which is a good example of gravity. And what it functions to do is pull objects toward the center of the earth. And then just to go over stuff, another force that I talked about is friction, which slows things down for the most part. Okay. Next question. What does Newton's first law say about things at rest? Nothing? Okay, okay. Also, just in general, you guys don't have to raise your hands. I promise with me. You don't have to raise your hands. Just you can just unmute and say the answer if I ask a question.
Does it like if it stays, and if you push it, like it moves?
Mm-hmm. Yes, yes, yes. In the,
Anateria.
fan. Hmm?
Anateria.
Sorry, I didn't hear you.
Anateria. Yes.
Oh, I see what you're saying. Inertia. Yes, yes,
Yeah.
yes. Yeah, sorry. I wasn't say is like, in the proper terms, what like you'll see whenever you go into like your next science class or how they'll explain Newton's laws is they'll say very long-winded statement that I said like 1,000 times, I think, already. But basically, an object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an outside force. Um, and I know, Julie, you said, oh, if we don't, if we don't move something, it's not going to move. If it's at rest, it'll stay. And if we push something, it'll go. And that pushing is considered to be an outside force in this case. But other outside forces, like I talked about earlier, they aren't as obvious as you might think. For instance, the back to the soccer ball example. Friction is sometimes a force that we don't really think about a lot because we just, see it as how things normally work. But the ball touching the grass would be considered an outside force. But overall, yes. And the answer I have here is they stay at rest until acted upon by a force, which you guys answered. Um, the next question is, why is it harder to pull a full box than an empty one?
Um, it's harder to push um a a box like filled with like stuff
Mm-hmm.
because the box is like filled with a bunch of stuff like books or shoes or or hats or
I
some
like
other
where you're going.
things.
I like where you're going. So something has more stuff in it. If a box has more stuff in it, what does it have that's greater than the empty box?
But um wait wait it's like it has more force to it.
I see what you're saying. I see what you're saying. The word I'm looking for is mass, or you to say like it's heavier.
Oh, mass.
Yes,
Okay.
yes, yes. But the reason why, I don't know how much your teachers might care about it in like your current science classes, but moving forward, whenever you get to like higher levels of science and higher levels of maths, um, it's better to use the word mass instead of weight or saying, well, this is heavier than this, because have you guys ever heard that on Earth you weigh a different number than you were to weigh on the moon, let's say, on a different planet? You weigh more or less a different amount. Same. Okay. I don't know if you guys have heard that, but it's true. You weigh different amounts on each planet, which has to do with the planet's gravity and such. But basically, someone's mass, which is call back to my last lesson, which is how much matter is in something. That remains the same on all planets, regardless of where you are, which is why we can say here, if you want to say it in the best scientific terms, the reason it's harder to push the full box than the empty one is because the full box has more mass than the empty box, which means that it's going to require more force to make it move. Okay, that was it for today's lesson. Do you guys have any questions?